Hello, welcome to my channel. So what I've done is I've set up a VR character that uses the built-in character class in Unreal Engine to use physics and jumping and all of that fun stuff, but it still locks the camera, or it still locks the capsule of the character to the HMD position. So I'm going to show you a little bit about how that looks here, so just give me one moment. So as you can see, I currently have the seated mode enabled, so even though I'm sitting down, I am at my maximum height. And I do apologize that I've got my Guardian here. Actually, I'm just going to turn that off really. I can't do it while I'm editing, but I'll turn that off for the next one. Basically, what's going on here is I'm at the perfect height of my capsule, even though I'm seated, because I have seated mode enabled. What I can do here is I can walk around, I can rotate. Rotation is a little fast right now. We will be fixing that in the tutorial. However, you can see I can walk up to this wall here, and if I move my head to the right, you can see that it actually pushes me away from the wall, because this capsule here, my collision, is always staying in line with my camera. So when I move my head, it's actually physically moving the character based on the collision with the capsule against that wall, if that makes sense. So this is what we're going to be setting up. I'm going to turn off this Guardian, and then we'll get started. Okay, so the first thing that we're going to do is, just so we have a little bit of a base to work off of, just because we're going to need to copy something out of it in a moment, you're going to want to go to your virtual reality BP and your blueprints. And this is just going to be contained in the VR template project that you can start with Unreal Engine. As you can see, I've already created my own map and just put a little bit up here to test out the collisions with the character. So once you've done that, we're going to open this motion pawn controller. And I'm just going to get that on the screen here. And what we're going to want to copy out in a minute is just from the begin play node, which you can find if you drop this down and double click on begin play. We're just going to want to copy all of this. So I'm actually just going to copy that now. And if we come back out here, you're going to want to create your own folder just to keep your own stuff in. I'm going to go into blueprints, characters, and you can see my base here. I'm just going to create a new blueprint, and we're going to use the character class. I'm going to call this BP VR tutorial. Okay, we're going to open this up here, and there's a few things that we want to set first. So this stuff isn't going to be necessary. It is going to be set up manually or automatically, but just for us to get a little bit of visual, what we're going to do is we're going to set this to 105. And this part is important. I'm actually going to change the capsule radius from 34 to 44. And that just helps make sure that when you walk up to a wall, it doesn't look like you're like literally nose planting the wall. You know, it just gives you a little bit of buffer. And it helps stop the experience from becoming too cross-eyed, if that makes sense. So with that capsule selected, we're going to add a scene component. I'm going to call this VR Origin. And with that still selected, we're also going to add a camera. And then all of this we can also just leave right here as well. And then going into the character movement, we're going to go to the max walk speed under the character movement walking. And we're just going to set that to 400. Okay, so now that we've got all of that done here, what we're going to want to do is we're going to want to go into the event graph really quick. And what I'm actually going to do is I'm just going to add another graph in here, and I'm just going to call it the input graph. And so anything that has to do with controls, we're just going to put here. And we can set this up really quick just because it is going to be the basic character movement that everyone's most likely familiar with. So because this was the basic VR template, we do have some of the VR controls already set up. So what I'm going to do is I'm going to go motion left X, motion left Y, and this is just going to control the movement, and then motion right X is going to be our rotation. And then we can take these here, and all we want to do is we want to add movement input to both of these, and we just want to add it from the direction that our camera is facing. If you want to set it up later so that you've got it based on the controller facing or anything else like that, you can go ahead and do that here. But for now, we're just going to base it off the camera, and I'm going to get the world rotation of the camera. And then I'm going to split this here, and I'm going to make a new rotator using only the X value, which is just going to make sure that the pitch and the roll don't play into this at all. It's only going to take from the yaw. And that's just going to make sure that if we look up and down, it's not going to adjust how fast we're moving. So with that, we are going to get the forward vector, and we're going to get the right vector. I'm just going to take those here, plug them in respectively, and then the axis value can go into the scale value for both as well. Okay, and then this is going to be our proper movement once we get everything set up with the camera or the HMD. And then what we're going to do is we're going to take this stuff here. What we're going to do is here we are just going to add yaw, the controller input yaw, do that, and what we're actually going to do is we're going to multiply this by a couple of things. So we're going to take this multiply node here, drag it off. Then on the second one, we're going to get the world delta seconds. And this is already handled in the add control input yaw, but the main reason we're adding this world delta seconds is just to slow it down immensely. It's just going to help with VR to stop motion sickness and everything like that. And then we're going to come over here and we're going to create a variable. We're going to call it rotation speed. We're going to make it a float. And I'm just going to set it to something like, let's say 35. I'm doing 35 because when I was testing this earlier, 20 was a little slow. And you know what? Yeah, let's just go with 40. If 40 is too fast, we can fix that later. And this is going to be all of our movement. That's it. Now we just have to set up everything that goes on the event graph, and this is where a lot of the main stuff happens. So the first thing we're going to do is we're just going to clear some of this initial stuff we're not going to need. Bring the event tick down, and then for the begin play, this is where we want to bring in everything here. So make sure you also grab this initial sequence, and then we're just going to paste that in, and connect it to the begin play, and then I'm just going to clean this up a bit. And then down here, it's adding in our motion controllers. So we want to come up here and we want to create these variables. And then you also want to make sure that the one that's connected to the right is set up to use the right hand. And then I'm just going to drag both of these above rotation speed for my own sanity. And finally over here, I'm going to disconnect the targets and connect these here. I don't know specifically if there's any reason why they avoid doing this. If someone watching knows, perhaps leave a comment. I would be very interested in knowing if there's actually any particular reason to avoid using these off pins. But for now, that's how we're going to set it up here. And this is going to add our motion controllers in. And everything else that we have set up here is just going to set up the HMD floor height, depending on whether you have SteamVR or Oculus. Everything that I teach in this video is going to make a fully adjustable character for any size, and it's going to work for Oculus, HMD, and SteamVR. So with all of that out of the way, moving along now, I'm going to align the event tick down here, and there's just a little bit more that we need to do. So we're going to create our first function. So come over to the functions here and hit plus. And we're just going to call this update underscore align collision to HMD. And what this is going to do is it's going to make sure that when we move our camera, like when we move our head and it moves the camera through the scene, it's actually going to keep the collision in line with that HMD position. So what we want to do is we want to take our camera and we want to get the world location. Okay. And then we want to break that. And what we want to do is we want to get the actor location. We're going to break that as well. And then up here, using the X, we want to make a vector. Add the Y. Then we're going to do the same thing down here. And then for the Z, we want to set them both to the actor Z. Okay, so once we've got these two here, we want to subtract them from each other. And what this is just going to do here, if you were to work out the math, is it's going to take the camera location and it's going to subtract from the camera location the actor's location, which will be in a lower Z coordinate than the camera location. So when we subtract those two values, it's going to place the camera right in the center of where the collider is going to grow up and down. Okay, and then what we're going to do with that is we are going to take the capsule component here. We're going to add world offset. And so that is going to take that distance in between, that extra bit. And then we're just going to add that as a delta location to the world offset to the capsule component. And that's just going to make sure that that capsule is always adjusted to be the offset from itself to the camera. And then finally, after we've done that, we also want to take the VR origin, because every frame this is going to update the position of the camera as it moves the capsule component. We just want to make sure that we take this here. We want to negate it. And then we just want to take the VR origin and we want to add a world offset to this as well. And we just want to add the negated vector. So when it moves the capsule component to be in position with the HMD, it's going to add an exact opposite amount back to the VR origin, just to make sure that the camera is not actually moving. It'll move the capsule and then it will put the camera right back to where it should be. Okay, so that's going to make sure that our collision stays in place with our camera. And then if we go back, we're going to create one more function here. And we're going to call this update_collision height. And this is just going to make sure that the height of our collision is always in place with the height of our HMD. So the first thing we're going to do here is we're going to go line trace by channel. And we're just going to be casting a line from the camera. So we want to get the world location. And then we just want to subtract a vector. And then we're going to split this here. We're going to be subtracting only from the Z. I'm just going to do something like 50,000. We just want this to be a very long line, going from the camera's world location downward. Okay? What that's going to do is it's going to find the location of the ground, no matter where we are in the world space. And so the first thing we're going to do is we're going to break this here, because we're going to want to know what that distance is. This is going to be what adjusts our height from the ground. And there is another variable that we're actually going to want to create here. I'm just going to do that now. It's going to be the collision max height. And what this is going to do is, like I said, the capsule is going to adjust to the height of a person. And the reason we have this collision max height is so that if you're jumping off the ground, the collision max height is just going to keep a value for what the player's maximum height is. And then so when you jump and stuff, the capsule just isn't going to get any taller than the player possibly can. So it's just going to keep that distance from the ground so you can still jump over stuff and all of that. So I'm going to take this distance node here, and what we're going to do is we're going to drag off of that, and I'm going to go map range clamped, and then I'm going to grab this collision max height and punch it into the in range B and out range B. So what that's going to do is it's just going to take the distance and it's going to exchange it at a 1-for-1 rate, clamping it between 0 and the collision max height. And then what we want to do is we want to drag this into a select float. And we're going to create one more variable here. We're going to call it clamped collision. I'm just going to make this one a boolean. and connect it here. So what this is going to do is it's going to tell us whether or not we are going to be using the clamped collision. And this would be nice just for, say your game doesn't have jump, and you want to be able to detect whether your player is going on their tippy toes, or like just keep it really realistic like that. This would allow you to keep the height of the capsule completely in line with the player at all times based on the height that you want to set up. But because we are going to be using a system that does include jump based on the project, we do want to have this option in here. So I'm just going to plug that in here. And for now, I'm going to keep this off, just so you can see what it looks like when it's not clamped. And then I'll come in here later and clamp it, just because I know that this should be okay. And as well, now that we've got this all figured out, what we're going to set up first is the condition for if we're not touching the ground. So if we're not touching the ground, what we want to do is grab our capsule, set our half height. This is on false. And we're just going to set this to the collision max height divided by 2. Okay, so if we're not touching the ground, or if we're falling or anything like that, it's just going to make sure that our capsule is always clamped to the max possible height. And if we're not using a clamped capsule, then we should never be off the ground, like we should never be in a position where we're not able to detect the ground. So this will never happen anyway. It's just something that we want to keep here. And as well, we do want to make sure that this is divided by 2, just so that we're getting that half height. And then so what we also want to do is we want to take this capsule half height. We're going to connect it to the true as well. Now that we've got this select float here, that's going to tell whether or not we're using the clamped collision. We just want to copy this divided by 2 node over here. And then we are also going to create one more variable. We're going to call it the head height. And this is just going to allow you to add a bit of buffer at the top of the capsule for the head. So basically the collision max height, what that's going to do is it's going to move the camera into a position where it's at the exact top of that capsule. And so the head height is just going to add a little bit of a buffer. And so I'm going to say that's 25. Okay. And actually, I'm going to say that's 20. So what we're going to do is we're going to go up here and we're going to add a float. And we're just going to add that head height to the divided by 2. That's there. And we're going to add this to the capsule half height. So this should now keep the capsule height and position in line with the HMD. So if we come back to our event graph, I'm going to drag in both of our update functions and we can connect those here. And it has been a long time. We've done a whole bunch of stuff here and haven't tested anything. However, there is just one thing I wanted to clear up quick as well. There's just a little bit that we want to add to the top branch as well. And at the beginning I said that this was going to keep everything perfectly aligned with the camera. So basically when you do a VR setup, most of the time the origin of the character is at the ground. However, there needs to be a little bit here at the beginning just to make sure that this works with a normal character spawn, and just to make the system a little easier. So with this setup here, what we're going to do is we're going to select the VR origin, and we are going to add relative location. And this is just going to move the VR origin dependent on the capsule height all the way down to the bottom of the collider, just to make sure that from the start everything is going to be properly set up and ready to go for us. So what we're going to do is we're going to take our collision max height value that we have set up here, and we're going to divide that by 2, because we do want to make sure that this, when everything gets set up by default, it is already going to take into account the max height that we're using. And we just want to minus from this our head height, and then we want to add a value of 45. This is something that you might have to play around with based on your own personal height, or dependent on the project you're making. However, 45 is a value that's worked well for me. And the reason we're adding a 45 here in between the head height and this minus node is actually because we're going to move this into a select flow. And then we are going to add here one more boolean called isSeated. And this is just going to let us decide whether or not we want our capsule to either remain at the maximum size at all times, which is going to be this here, or to be set to a default value of 0, which means we are not going to be adding any extra bit here for the seated position. And I was in the middle of saying it there, but I cut myself off. The reason that we minus this 45 here is because now that we've added the select float, we're actually just going to add that 45 back in. So we're just going to take this select float and plus 45. And then from here, I actually want to add in another float minus float and bring this down to the bottom. Okay, so what we're actually going to do is we're going to take the capsule component and we're going to get the capsule's half height. Whatever it is by default. And then we just want to minus from that capsule half height 45 plus that initial value for whether or not we're seated. And again, this 45 value might have to be something that you have to play with. I put this in here specifically because the floor level for my character, when I reached down, my hand would go through the floor. And so 45 was just a good value for me to make sure that when I reach down, the hand is at least somewhat lined up with the floor well enough that it's not a huge deal. Again, that might just be something that you have to mess with based on your own height or your own project. I just figured I would mention that now. And then what we're going to do here finally is we are going to multiply this by a -1. And what this is just going to do is it's going to take the negative value here, and it's just because we are going to be minusing that from the capsule half height, it is actually going to still give us an offset value. And so what we want to do is we just want to actually make sure that that offset value is going to be a negative, so it's moving our origin down to the bottom of the capsule. And then finally we just want to split this vector here, because we are only just adding this to the Z. We can just do it easily by doing that. And I actually think that should be pretty much most of the logic that we need in general. So I'm going to leave seated off here just for now, and climb to collision is off as well. And I'm going to jump in and I'm going to see if there's anything that we maybe missed. What we have to do as well, once we've set up our character down here, we just want to make sure that we've got a game mode set up, and then you want to make sure that you're loading in with the right character. So we just want to load our VR tutorial, and now I'll see you in the game. Well, I still missed a step, I apologize. Okay, so what you want to do is you want to come in here to your character, and we want to be able to visualize what's happening. So you want to open your capsule component, and then come up to rendering, where it says hidden in game, and just uncheck that so that you're able to see your capsule. Now I'll see you in game. Okay, so you can see here we're in game. The capsule is properly following the height of the HMD. We are not in seated mode, so we are actually pretty close to the ground right now, which is totally fine. If I reach down, you can see that that value of 45 kind of makes sure that my hand stops from going through the ground. It's actually a little different than it was before, so it's quite possible that I may have changed something. But yeah, other than that, this seems to be working okay. However, yeah, so you can see that rotation value is just fine at 40 there. What I'm going to do is you can see if we come walk up to this wall, everything looks all hunky-dory, but I'm going to show you why this doesn't work. So basically, if we come over here and we look at this wall, you can see that if I like move the joystick while I'm moving my head, it sort of like does this weird glitchy clipping. And so what's going to happen here is if I actually stop moving, I guess you can't see my controllers, but if I stop moving and then I move my head, you can see that I'm cutting through the wall. And then if I move, it's actually going to teleport to the other side of the wall, because the collision thinks that we are making it through the wall there. And that is just happening because we are not actually sweeping the collider that is surrounding the character. So the way collisions work is when you walk around, it's doing constant collisions. However, when you stop moving, the collider is actually no longer detecting anything, right? And so the way that you can make the collider detect things again is when you call something with the collider, you want to just call it using the sweep function. So I'm going to load back up the code and I'll show you that here. Okay, so we're back in the code here. And what you're going to want to do is we want to go to the function update align collision to HMD. And right here, where we're moving the capsule component and the VR origin, you just want to go ahead and select sweep. And what this is going to do is when it moves the capsule component and the VR origin, it's just going to sweep those collisions as if we're moving, even though we're not. And I'll just show you what that looks like here. Okay, so we've got the sweep collisions on, and I'm just going to stand up here because our capsule is not clamped right now, so I can show you that the capsule does follow my height perfectly. You can see this line here indicates that this is the top portion of the capsule, scaling perfectly with my head. And this is what I meant. I'll show you in a moment how the clamped one works, but you can see here that based on the head height that I've selected of 20, that this here is perfectly in line with my camera, because the top portion of a capsule here is 20. So if we didn't have that head height, the top of the capsule, the camera would actually be perfectly in line with that, and so there'd be no collision above our head. But anyway, so now that we've got that sweep collision on here, if we come back up to this wall, and we like headbutt the wall here, and we move back, you can see that we've actually been pushed away from the wall, because those sweep collisions are making sure that the capsule is still being affected by the things around it, even though we're not actually moving the character, right? And so that is how you go about setting that up. And there is one little thing that I want to show really quick before I switch to the clamped collision, and this is actually the main reason I have the clamped collision. So this is just going to be a bit of a project for you if you do want to use this unclamped collider. What I'm going to do here is I'm going to sit down so that we're smaller than the max height, and then I'm going to come over here, and I'm just going to go off this edge a little bit, and you're going to see that the capsule gets bigger because we're no longer on the ground, right? We are considered falling if you take into account... No, I'm sorry, I'm explaining that wrong. Basically what's happening here is we're detecting the distance between the ground and our HMD, right? So what that's doing is it's detecting where the ground is, and then it's moving our HMD into the proper position, and then it's moving our capsule into the proper position and readjusting the VR origin just to make sure that everything is correct. However, when we do this, the distance between the ground and the HMD is now more, because our line, if you can look at the bottom of the capsule, it happens as I move my head over the edge, because that's when we're now detecting a deeper ground. So there are a few ways that you could go about fixing this. You could do it by creating a few more line traces and just constantly detecting whatever the lowest variable of ground is nearby. You could also go ahead and do something more along the lines of just straight up detecting whether or not the player is jumping. So after you've hit a jump input, set a mode to jumping, and then that would just set the collider to then use the ground distance dependent upon its distance variable of whether or not you're doing this, you know? But the way I've solved it for my project, and the way that I'm going to want things to work for me, just because my game is going to be played seated, is to have a clamped collision so that the maximum height cannot go over a solid value. And that is probably going to be the way that most people are going to want to do it, just because even if your game is a normal game and you've got jumping or whatever, even if you don't want to have the seated position, you're probably still going to want to clamp your collider to some maximum value. And so when you do that, what you can actually do is set it up so that when the game itself starts, have the player be in whatever position they're going to be in, so like their standing position, and then that's going to detect what their maximum height actually is, and then it will save that float. And you can just store that however you want, however you're saving the player's data, and that would give you a perfect scaled value for whoever is playing your game. There's no extra math involved on your end, and that would be perfect. But really quick, I'm just going to go in, I'm going to set up the seated position, turn on the clamp, and show you what that looks like quick before we go. Okay, so you could see before that the collider would always match the height of the HMD. However, you can see here now it's exactly like my original one was, where this line is actually below my eyes, and then if I duck down here, then it starts to follow me. Because I'm in the seated position, it's always putting us to that maximum height. So you just want to make sure that if you do need to make adjustments for your game, I've done my best to explain what all of the math is doing. So you should be able to go in there and adjust that. But you can see now, as I come over this edge, it's not adjusting the capsule. Because we're constantly being set to our maximum height, there's nowhere else for the capsule to go. Right? It can only be its size. And we can swap up the edge here, and you can see that we do fall down with gravity. And I don't have a jump plugged in, but you could imagine that it does the same thing. It just does, it does this, but if we're jumping, you know? Falls perfectly with gravity. And again, we can headbutt walls, and it moves us around as if we've actually collided with the wall. Okay, so I hope if you're trying to work on a VR game like I am, that this was helpful. I was really trying not to have to spend money to make a system that was at least somewhat like the system that I've been trying to figure out. So this is at least usable. I hope this was helpful, and I hope you have a great day. Thanks for watching.